In this video, we're going to discuss the slope of a line. So let me draw a few lines for you. Let's say we have this line, maybe this one, and one more. Let's say this line here. The first thing to notice about each one of these lines is that they're all going from the left to the right. They're going kind of upward, right? So if we look from left to right, you can see this is going up. This one is going up a very, very small amount. And then this one is going up a lot. So from left to right. The slope of a line is the steepness of its line. So pretend like you're a little car on one of these lines. And if you were driving this car from left to right, so we're starting at the left part of this line and looking towards the right, you notice that you're going up. And I can actually do this for each one of these lines here. And what you want to think of is kind of like these lines are ramps. And you can see that the steepness of this ramp, well, this one's not as steep as this line on the bottom. You see, this one's pretty steep because you're really going up. And then for this one, you would say this one's kind of like in the middle of steepness between the three because you're still going up, but you're going a lot to the right as well. And then finally for this one, you're barely going up at all. You can see that this line is almost vertical. I would say a horizontal. You can see that a horizontal line would kind of go all the way straight here. So it's kind of going up too, but at a very small amount. And the steepness of a line, or a steepness of a ramp, is called the slope of the line or the slope of the ramp. Now, what I'm going to do is I'm going to give you numbers that measure the slope of the ramp. The bigger the number, the more steep it is. For example, I would give you something like this one. Maybe I would say this has a steepness of 5. And you would expect that the steepness of these two to be smaller. So maybe this one has a steepness of 2, and maybe this one has a steepness of 1/2. So if the line is going up when you look from left to right, then the line is going to have a steepness of, the number is going to be greater than 0. So something with a small number that's really close to 0 is going to have barely any, you're barely going to be going up at all, like this one here. But the bigger the number, you can see, the steeper the line's going to be. So that's something you want to keep in mind. Now here we're kind of going up for each one, but what if we're going down? So let me give you another example. Here, let's draw 3 lines again. But from the left to the right, let's say they're going downward. Okay, so you can see all of these lines are going downward when you look from left to right. And if you were a car on these lines, driving, now again from left to right, you would say that the most steep line is this one here. This one you're really going downward. This one's somewhere in the middle. You're going downward, but not quite at the rate that you're going down here. And this one is the least steep. And again, what we're going to do is I'm going to give you some numbers to describe the steepness of these lines. Now these numbers are going to be negative. The negative will indicate that you're going downward. So if I give you a positive number, you're going upward. And if I give you a negative, you're going downward. And the closer they are to 0, the less steep they are. And the further they are from 0, the more steep. So for example, this line here we might say has a steepness of -1. And then this one would be, let's say, -2, and maybe this one is a -4 or something like that. We're going to be more careful about the numbers in a minute, but I just want to give you an idea of what slope is. So the bigger the number is, the absolute value of the number, so the absolute value of this is 4, And if it was a positive 4, you can see it's further away from 0. So the steeper the line is going to be. If it's negative, then it's going down. If it's positive, it's going up. And the closer you are to 0, the more flat the line is, the more horizontal it is. And horizontal means, you have like a line, like the horizon, just like that. So you can see this one's pretty close to a horizontal line, so the steepness is going to be closer to 0. The steepness of a horizontal line where you're not moving up at all, its slope is going to be 0. So that's going to be the slope. And we're going to use the letter M to represent slope. All right, so let's actually do some problems involving slope. Now what I'm going to do is I'm going to give you a couple of points. And we're going to graph those points. And from any 2 points, you can construct a line. And using that line, we can find the slope of it. So here are my first 2 points I'm going to give you. I'm going to let P be the point 1, 1. And let's let Q be the point -2, -1. Let's graph them over here. In fact, I'm going to zoom in so we can see the points really well. Just a little bit more, I would say. Okay. Let's make dots for these 2 points. So 1, 1 would be right here. I'm going to put P here. And then Q is -2, -1. Okay, from these 2 points, we can make them as pretty big so we can see them. We can construct a line. So what I'm going to do is I'm just going to draw a line through them. And it's going to continue to go that direction and this direction. Now it would be really good to use like a ruler or something so you can make a perfectly straight line. Because I'm using the software, I don't have a ruler to use, but you should do that, or use a piece of paper, like fold it in half or something and try to make a straight line. Now, from these 2 points, we can talk about the slope. So remember, what you want to think about is a car going from left to right. So we're going basically in this direction. So we can put the car at the bottom here. And what we're thinking about is how steep this line is. So I'm actually going to give you a formula to calculate it. So let's write down the definition over here. So the slope of a non-vertical line L containing 2 points, so we're going to say the points P and Q, is defined as M. Let's do a different color here so we can really see this. Let's go with the red. M. Now that's the letter we're going to always use to talk about slope. We're going to say M. We're going to say y2 minus y1 over x2 minus x1, where the point P is x1, y1, and the point Q is x2, y2. And it really doesn't matter if you let P be x2, y2, and Q be x1, y1. You just always have to follow this, this equation here. So whichever one you let be x1, y1, and the other one be x2, y2, if you take y2 and you need to subtract y1, you got to do the same thing. You need to take x2 and subtract x1. You can't change the order of these. So you can't do something like y2 minus y1 and then x1 minus x2. That won't work. You'll get the wrong slope. So we're going to be careful about this, and we're going to do some problems, so you'll see what I'm talking about in a minute. Okay, so let's calculate the slope of this line right here. Now I'm letting P be the point 1, 1. So up here, I'm going to put 1, 1 is x1, y1. And then the other point right here is Q, which is -2, -1, and that's my point x2, y2. Let's calculate the slope. So I'm going to take y2 and I'm going to subtract y1. So I'm going to take -1 and subtract 1. So -1 minus 1. Then on the bottom, I'm going to take x2 and subtract x1. So I'm going to follow the same thing I did before. I'm going to take this, I started with this one and then I went to this one. So I'm going to start with this one, which is -2, and then subtract this one here. And I get 1. So overall, I'm going to get -2 over -3. And if we divide a negative by a negative, we get a positive 2/3. And that is our slope. So notice that this number is kind of close to 0. It's 2/3 is smaller than 1 because 1 is 3/3. Okay, so that tells me that this line isn't very steep. Of course, it depends on how you draw this plane. You'll notice that I have my tick marks pretty close together. So the further they are apart, the closer this line looks like being a horizontal line. And how can we interpret this number? What is it about 2/3? What does that mean? Well, 2 divided by 3. 2 is the change in y. So that's how far up you go from the point Q. And then the 3 is how far to the right you go from the point Q to get to this point P. Notice that you have to go up 1, 2, and then over 1, 2, 3. And you're right on the point P. You could also go to the right 3 first, so 1, 2, 3, and then up 2 to get to this point. So it's like a staircase. So it's how far you have to go go up and to the right, or you could say to the right and up. So the top number, let me erase some of this so I can write it right here. Also, make sure that you pause the video, or you can go back at any time and write down the definitions. That way you have them in case I erase them. So we found the number 2/3. This 2 is how far you go up. And this 3 is how far you go to the right if you start at the point Q. Okay, so we go up 2/3 or over 3 and up 2. And we want to think of the slope as the steepness of this staircase. Now we can find more points on this line using the slope. So we have 2 points, but I can give you more points. For example, if I start with the point P, if I follow this slope, if I go up 2, so 1, 2, and then over 3, 1, 2, 3, this will be another point on the line. So I could ask you for one more point, and you would say, oh, the point looks like 4, up 1, 2, 3, 4, 3 would be another point. Now you have to be very careful with your sketch here. You want to make sure it goes so up 2, over 1, 2, 3, you go through that next point, and you can find that as well. But you could also go downward because this line goes on forever in this direction. So let me erase this, and let's find a point kind of below Q. Okay, so to do that, what do we have to do? Usually we go up 2 and over 3, but this is also, you could think of it as also being how far down and to the left you have to go. So you have to switch both of these directions. So I can go to the left 1, 2, 3, and then down 2, and that would be another point on this line. And this looks like the point -5, comma, -3, right? 1, 2, 3, yeah. And we can continue in this this way. We could go to the left 1, 2, 3, down 2, here's another point. And notice that this line, if you look from the left to the right, is going up. And that makes sense because we got a positive number. Let's do another example. Let me give you 2 more points. Let's say we have the points 2, 2. Let's call that point P. And the point Q is 3, 8. Let's find the slope of the line that passes through P and Q. You don't have to actually draw this to find the slope, but I'm going to draw it just so we can visualize it. So I'm going to put 2, 2 and 3, 8 on this graph. So let me zoom in. 2, 2 is right here, so that's the point P. And the point Q was 3, 8. So here's 3 and up 8. So 5, 6, 7, 8, right here. Now we're going to draw a line through these two. Now this is going to be a steep line. If you make your XY plane a little bit wider, so maybe you would, instead of having a 5 here, maybe you put like, this is 1, this is 2, and so on. You could see it a little bit better. Let's see. I'm going to do my best to draw a line through these two. It might not be perfect because I have a hard time drawing on this software, but okay, let's try one more time. So something like this. I think you get the idea. And you can see this line compared to the one we did a minute ago. This line is not so steep. It's going up and to the right. So we should expect this one, because it's going up and to the right, it should also be a positive number for the slope. You can actually just find it by just looking at this line, but we're going to use the equation as well. And this number should be bigger than 2 divided by 3 because it's more steep. So again, we're going to let P, which is the point 2, 2, we're going to let that be x1, y1. And the point Q is going to be 3, 8, which is x2, y2. And now let's use the equation for the slope. The slope, M, is y2 minus y1 divided by x2 minus x1. Okay, so y2 minus y1 is 8 minus 2. And then x2 minus x1 is 3 minus 2. So we get 6 over 1, or just the number 6. Now, any whole number can be written as that number divided by 1. So what I would do on my homework is I would write it like this with the understanding that it's 6 divided by 1. Which means we go up 6 and to the right 1. Remember, if you have a positive number, you're going up and to the right, or down and to the left. Okay? So we're going to go up 6 from P. You can see 1, 2, 3, 4, 5, 6, and to the right 1 to get to Q. We could also go down 1, 2, 3, 4, 5, 6, and over 1 to get to my next point, if I had just continued this line. And then you could also go up 6 and over 1 to get to another point. Of course, there's lots of points in between, and you can find those as well. But we're just going to focus on this piece right here. Okay, so we've seen 2 examples where we got positive slope. Let's do one more example, but this time let's do an example that has a negative slope, just so we know what to do. So I'm going to copy this. I'm going to move it down here. Zoom out a little bit. Let's put this here. And let's try another example. Let's say we have the points P is equal to -2, 1, and Q is the point 3, -1. Okay. Let's find the slope of the line between these 2 points. So what is the slope of the line through P and Q. So let me just put equals here. So this is the letter M, and it's y2 minus y1 over x2 minus x1. Again, it doesn't matter how you label these, but I'm going to say this one is x1, y1, and this is x2, y2. Okay, so let's plug all this information in. So y2 is negative 1 minus y1 Let me just make sure that's right. So negative 1 minus 1, and then we take 3 and subtract a negative 2. So 3 minus a negative 2. What do we get? Well, on the top we get a negative 2, and on the bottom we get, becomes a plus, and this is a 5. So negative 2/5. Let's draw this. So the point negative 2, 1, I'm going to zoom in. Negative 2, 1 is right here. So that's the point P. And the point Q is 3, negative 1. So 3, negative 1, that's Q. And if we drew a line through these 2 points, it would look something, oh man, I'm going to have trouble. You know what? The bigger you make the point, it's going to lie on this line, you see. Now they're really big points, so they definitely lie on the line. Okay, so we have a straight line. Make sure you draw a better line than this one. And you can see that this line is kind of going downward. So if you look from the left to the right, it's going down, which goes with the fact that this slope is negative, okay? And to get from P to Q, what do we have to do? We can go to the right 1, 2, 3, 4, 5, and down 2. So we can go to the right 5 and down 2. We could also, if we went from Q and we want to go back to P, we can go up 2 and to the left 5. So this is also, we go up 2 and to the left 5. And notice that I moved the negative down, and I'm going to tell you why I did that. So an easy way to remember how to move. A negative number, you can move this negative if it's in a fraction to the top or the bottom. And what that does is it's going to switch the direction you're going to go. So this numerator was always up. So now you're going to think of the numerator being up or down. And if it's negative, it's down. And if it's positive, it's up. The number on the bottom is going to be how you go to the left and to the right. If it's a positive number, you go to the right. And if it's a negative number on the bottom, you go to the left. So like if this was just 2 over 5, you would go up and to the right. But if I stuck a negative in the numerator, then instead you could say I'm going down and to the right. And that's exactly what we did here, right? You could say I'm going down 2 and to the right 1, 2, 3, 4, 5. But negative 2/5 is the same thing as 2 over negative 5. So you could go up 2 and to the left 5 because I switched the right to the left. So I'm doing the opposite. So you could think of up and down as being the numerator and left and right as the denominator. And if it's positive, it's up. And if it's positive on the denominator, it's also this direction to the right. If it's negative on the numerator, it's down. And if it's negative in the denominator, it's to the left. Okay? So here I said we can go up and to the left. So that's what you did from Q. You go up 2 and to the left 5. So again, you could go down 2 and to the left 1, 2, 3, 4, 5. right here, this line would go through this point and it would continue on onward. Again, I'm having trouble drawing this, but if you do a really good drawing, you'll see this if you do a good sketch. Again, to get to the next point, you can go up 2 and to the right 5. 1, 2, 3, 4, 5. This would be the next point on this one. So maybe if we make it like this, I'm going to erase this thing here. You can see that right here. This would be a more accurate sketch of the line. I also said in one of my examples, I think up here, like with these positive slopes, we could go up and to the right, but we could also go down and to the left. And that's because 2 over 3 is the same thing as negative 2 over negative 3, right? And so this would switch the sign of up to down, and this would switch the sign to left. So that's just how you can keep these straight. You can always think of it as, if I have a positive slope, I should always be going up and to the right. And if I have a negative slope, I can go up and to the left or down and to the right and stuff like that. Okay, let's move on. The next thing I want to talk about is when we define slope, which I said was the letter M, we said it's the line containing P and Q has this slope. It's the rise over run, so how far up you go, divided by how far down you go. And we said that this line has to be non-vertical. So what if we have a vertical line? What is the slope of that line? So a vertical line is a line that goes straight up. This is vertical. So when we have a line like this, the slope is undefined. What's going to happen is when you try to find the slope, which is y2 minus y1 divided by x2 minus x1, you're going to get a 0 on the bottom. Let me give you an example. Let's say we have the points 5, 1, and 5, 3. If you graph these 2 points, so 5, 1 would be here, and 5, 3 would be here. So the line going through these two would be straight, like a vertical line. And then we calculate the slope. We say M is equal to, we can go 3 minus 1 divided by 5 minus 5. So we get 2 divided by 0, and if you remember, you can't divide by 0. This is undefined. So the slope of a vertical line is undefined. You should remember that. Now what if we have a horizontal line? Now we talked about this earlier. We said for a horizontal line, the slope is 0 because we're not really going up or down. M is going to be 0. So let's look at an example. Let's say we have the points 2, 3, and 4, 3. If I was to graph this, so 1, 2, up 3, and 4, 3, the line going through this would be a horizontal line. And so what's going to happen in the equation? The equation is the change in y, which would be 3 minus 3, divided by the change in x, so 4 minus 2, which is 0 over 2, and 0 divided by any number is 0. So if you have a horizontal line, your slope is going to be 0. Okay, let's do a couple more problems. Move down here a little bit. Okay. I want to draw a line whose slope is 3 divided by 4 and passes through the point 1, 1. Let's see if we can do this. Okay, I'm gonna erase this. I wanted to have the plane here, so let me move it up a little bit. Okay, so let me scroll back up here. So I want you to draw a line whose slope is 3 over 4 and passes through this point 1, 1. Do you think you can do this? Maybe take a minute, pause the video, and see if you can sketch such a line. And then check it with me. So unpause the video and see what I do. All right, so I want to sketch this line. So the first thing I'm going to do is I'm going to plot this point 1, 1. The point 1, 1 is right here. And then it has a slope of 3/4. So 3 divided by 4. Now we remember that this is how far up we go and to the right. Or, because we can write 3 over 4 as -3 over -4, it's how far down and to the left we go. Remember, these negatives change the direction. So to find another point on this line, we can just go up 1, 2, 3, to the right 1, 2, 3, 4. And all I really need is 2 points to plot this line. And I'm done. But I could also go from this point and I could go down 3, 1, 2, 3, and over 1, 2, 3, 4. And this would be another point on the line. So I might ask you on your homework, what is another point on this line? And after you plot it, you could just look at the picture and you could say, well, I went from, this point was 1, 1. What is this new point? This new point is 5, comma, 4, because here's 4. And also you could give me a different number, a different point right here. You can see that this point is -1, -2. That's how far down I go. So let me erase that. I go down -2 to get this point and over from 0, 1, 2, 3, so -3, because this is the negative x direction. So here would be 2 more points on this line. Now we could actually get this from without drawing the line. To get these 2 points, notice that this is my y, my change in y, and this is my change in x. So if I'm going up, if I look at this point 1, 1, let me write it over here, 1, 1. To go up, well, that means I'm going to have to go up 3, which would make this number now 4, if I add 3 to it. So let me write it down like this. I add 3 because I'm going up. That'll make this 4. And then I'm going to the right 4 because that's the number on the bottom. So I'm going to add 4 to my x because x is how far left and right I go, right? Because that's the x-axis, left and right. So if you add 4 to number 1, you get 5. And see, you get this point 5, 4, which is exactly what we had here. Now we could also find this one. We had the point 1, 1, and we said that we could also think of it as going down 3 and to the left 4. So we could subtract 3 from this y coordinate and subtract 4 from the x coordinate to get -2, -3, which is exactly what I got when I drew this picture. Let's do one more. I'm actually going to erase this, so make sure you have everything copied. Okay, I'm going to draw it on this graph. I'm going to change this point and I'm going to change the slope, and let's see if we can draw a line whose slope is, let's say, -5 over 4 and passes through the point 2, 3. So let's start off, let's see if you can do it, and then check and see if you get the same thing I get. Okay, so I'm going to plot this point 2, 3. So this is 2 up 3. So here's my point. And now I just need to figure out what to do with this slope. So negative 5 over 4 means go to the right 4, I can keep this, and go down 5. Or I can write it as 5 divided by negative 4, just move that negative to the denominator, and that's going up 5 and to the left 4. I think I'll do actually both. So we're going to go down 5, 1, 2, 3, 4, 5, and to the right 4, 1, 2, 3, 4. And this point, it looks like it's 6, negative 2. And then we can also go up 5, 1, 2, 3, 4, 5, to the left 4, 1, 2, 3, 4. And this point looks like 5, 6, 7, 8, 2, negative 2, because we're with the negative x line. Okay, so you can draw the line going through these points. Again, I'm gonna do my best to draw using this software. Oh, this is actually turning out pretty well. That's good. So now I have my line, and this has a negative slope, which means I should be going down, and it looks correct. Okay, so I've drawn the line. Again, I could just use this point to figure out these 2 points. So I have 2, 3, and this is negative 5, 4. So this number is negative, which means I'm going down, so I subtract 5. And this number is positive, so I'm going to add 4. And if I do that, I'll get 6, negative 2. 3 minus 5 is negative 2, which is what I got before. I could also take the point 2, 3, and I could add, subtract 4 from the x, because I wrote the slope with the negative in the bottom. And then I can add 5 to the y, and I'll get 8 for the y and negative 2 for the x. Oh, I wrote these backwards. I'm sorry about that. Let me put them in the right order. Negative 2, 8. So I did get the right thing. I just wrote it incorrectly earlier. Sorry about that. So yes, we get the same answer. Before I end this video, I just want to talk about one more thing. We've mentioned it briefly, and I just want to state it again, just in case you see it on your homework. That's if you get a slope that's a whole number, positive or negative. So let's go with negative. Let's say we have the slope is negative 7. And let's say it passes through 1, 1. What do we do here? Whether it's positive or negative, you can always take a whole number and write it over 1, okay? So if we have the point 1, 1, now we can go down 7 into the right 1. 1, 2, 3, 4, 5, 6, 7, into the right 1. And there you've drawn your line. You just have these 2 points and you connect them. So if it was positive, if it was a positive 7, you would go up 7 and to the right 1.